Great. Thanks, Thomas. As you said, my name is Grant Ingersoll. I'm the CTO and co-founder of LucidWorks. We're primarily the guys who build Lucene and Solr, and then build stuff on top of that. A little bit of a advertisement first, and awesome, everything crashed. So I'll just stick to here. Let me bring Keynote back up, and hopefully it will be good. They were just warning me that there was issues with Keynote, so. Hopefully this will work, otherwise I'll have to export to PDF real quick. So a little bit of quick advertisement. If you like Lucene and Solr and you want to go to Austin, Texas, which is a great little town in Texas, we're doing Lucene Solr Revolution this year in October. It's a great time to come visit the US and visit Texas. So with that, let's get into, you've got questions, we've got answers. How many people here are working on actual question answering systems? One person. All right, you get to leave, because this is all more beginner level, all right? We're going to introduce what is question answering. We're going to take a look at some working examples, and we're going to talk about some of the details that go into building a question answering system. And I'm going to put some caveats along the way, and so at the end of the day, what I'm going to say is mostly true. All right? It's up to you then to figure out what works for you and your real system. But I think what you'll find is that if you go and look at what I'm talking about and you compare it to the state of the art, there's going to be some gap there, but the concepts and the ideas are about right. And then you can take and decide how much effort you want to put in to other things. So with that, how many people saw Watson play Jeopardy? Okay, so you guys are at least familiar with what question answering is. If you're familiar with search, you know we're usually returning 10 blue links. With question answering, as the name implies, I want to return the answer. Who is the current prime minister of Germany? Give me that exact answer, and it's got to be contextual, right? Because I can't just say, who is the prime minister 10 years ago or 20 years ago or whatever it is. I need to take into account all kinds of hints and information about who I am and where I am and all of these kinds of things, okay? And so that's kind of the end goal. And if you think about search in general, what most users are after are answers. So wouldn't it be great if we could actually give them answers? So in some sense, like question answering is the future promise of search. And you see more and more search engines are at least offering answers in select circumstances, okay? Like things like specific facts that they know or answers to questions that people ask every day, day in, day out. Hey, instead of doing a search, why don't we just put up the answer for that? And so let's start off with a little demo. And in this demo, it's based off of some code that I've written based off of a book that I've written called Taming Text. We'll talk about that a little bit more in a minute. But the idea here is that I'm going to take some set of information and I'm going to add some NLP on top of it. I'm going to mix it in with search. I'm going to do some fancy scoring. And I'm going to come back with an actual result. And so I've got a query that I'm sure all of you are thinking about right now. What is trimethylbenzene, right? This is at the forefront of your imagination, I'm sure. But I'm going to actually go and run that after I make this a little bit bigger. Can you see that back there? I'm going to go and run that. And what you'll see is, if I make that a little bit bigger, is I actually did, this is going and hitting Solr, it's doing a bunch of question parsing and all that stuff, and you can see that it's actually returning here an answer. 1,2,4-trimethylbenzene is a colorless liquid with chemical formula CH. It is flammable, flammable aromatic hydrocarbon with a strong order. It's a pretty good answer, right? Now, of course, hey, you know, the power of demo, I'm up here on stage. Of course, I picked one that makes sense. But we can also ask other types of questions like, who is 10-minute warning? And you can see that I can get back answers here as well. 10-minute warning was a hardcore punk band from Seattle, Washington. They became famous locally. And if I scroll down here a little bit, you can see that here indeed is the supporting content that I derived that answer from. So if you were doing raw search, you would get back this. If you're doing question answering, you can get back something like this. Which one's better? Depends on what you're looking for, but I think, for most of us, the quicker, faster answer is usually the better. If I'm really into 10-minute warning, maybe I want to know all of their background, but in this case, I don't know a lot about them. I don't know any of their music. Anybody know 10-minute warning in the audience here? Wow, one person. Get that guy a gift card. I think he wins the prize. I think you're the only person where I've given this talk that knows this band. But I could also ask other questions like, what is Berlin Buzzwords? Doesn't work. What happened? The system's broke, right? Well, in reality, we'll explain what's going on here. And that's kind of the power and the promise of question answering, and also some of the shortcomings of it, is that it doesn't always work. And so we have to be smart about how we think about question answering and how we integrate this into our system and feedback loops and all of that kind of stuff. So that's kind of a gentle introduction. Basic idea, though, is I want answers. And as you saw by the types of questions that I was asking, in this particular context, in my book and in the code that I've written, it's primarily geared around fact-based questions. I'm not asking what were the causes of, the U.S. Civil War, or when did, some complex thing that you could go do a whole PhD on. Right? We're just asking for facts. And of course, you can build things on top of a fact-based engine to ask more interesting questions. Find me all the content that compares and contrasts the U.S. Civil War, for instance, or whatever your fancy is. Like, you can start to layer on more complex things. But in this particular code set of examples, it's all about, can I find that little snippet of data that says this is the answer to this question, or at least this is the likely answer to that question. So all of this stuff is kind of based off of work that I get to do when I put my CTO hat on at LucidWorks, as well as in the book Taming Text. The book itself is a little bit out of date, but it's primarily geared towards people who have never built. They're engineers like yourself. You probably know Java or some other language, but you've never necessarily worked on search or worked on NLP before. And so the idea is I'm going to walk you through in a gentle way what are the concepts behind these things, and then show you working examples using open source code that either we, the authors, wrote, or based off of popular open source projects like Lucene, Solr, Mahout, OpenNLP, all of those kinds of things. So with that, I always like to start when we think about NLP by taking a step back. And I just want to warn you, like everything that you've done in your engineering career, if you haven't worked on these kinds of problems, is going to start to make you feel squirmy and a little uncertain of yourself. And the interesting thing is, like, when you start to think about text, it's filled with all kinds of different characters, right? There's a lot of evil people or evil kinds of text out there. There's noise, there's bad data, there's a mixture of good and bad data, there's mixtures of languages all in one document. There's people, believe it or not, on the web who actually publish lies. So what are you going to do about all that stuff? This is going to be your job. If you want to be an NLP engineer, you're going to have to spend a lot of time fighting these guys. So I like to think about it as, how can we go off and do this? There's people who are jesters. There's people who say things that look like they're actually serious, but they're not. It's called sarcasm, right? There's people who are really good at language, the Hemingways, the Faulkners, all these guys. There's people who write sentences that go on for multiple pages, and people actually think those sentences are beautiful. How do you train a computer to detect a sentence that spans 27 pages? That's your job as an NLP engineer. And then, oh, by the way, there's other things, like there's unicorns. There's really rare stuff. In fact, you're a unicorn. The fact that your name, probably, who you are, if you show up in text, chances are that's a pretty rare event for most of us. You know, we're not world famous All of us, so the odds of any one of us showing up in text and a machine being able to say, oh, that's Bob Jones right there, this Bob Jones that's sitting right in the front row, not very high likelihood that we would be able to determine that. And yet you're often asked when building these systems to be able to do this kind of stuff, right? The cool thing, though, is at the end of the day, we all get to be the heroes because we get to work on this stuff. But most importantly, just remember, no system will be perfect. Here's the other caveat when it comes to dealing with this stuff. I want you to, everybody know the English idiom, take it with a grain of salt. Again, that kind of goes back to, well, it's mostly true, but don't believe everything you hear here. I think when a lot of us think about NLP and machine learning, we think about all these fancy algorithms, you know, support vector machines or deep learning or all of these kind of really cool things, neural networks, etc. You're going to spend a whole lot of time on a whole bunch of crap work. Pardon my French there, right? You're going to spend time dealing with things like PDF formats. Anybody tried to extract text from PDF before? Raise your hands. Been a good experience for you? No? Why not? It's because it's a proprietary format. We're using open source tools to get it. Adobe doesn't publish the spec, all of that kind of stuff. You have to pay for it. Well, there's all kinds of those kinds of problems, and you're going to spend a lot of your time on those kinds of problems. Things like pre-processing, feature selection, sampling, doing validation and testing and all of that. You're going to spend a little itty-bitty time on the core algorithm itself. And guess what? In most situations, the algorithm is only going to move the needle by a tiny little bit. And so I always like to try to warn people ahead of time that you need to start simple, use tried and true approaches. Also keep in mind, what is the bang for the buck for you and your company, right? A lot of people want to add, for instance, really fancy NLP to their search algorithms, when in fact they would be 100 times better off just simply adding something like autocomplete to their search box. Right? So you may, as an engineer, want to go do NLP because that's really cool. But autocomplete, which is basically an engineering task at this point of adding a couple more servers and being a little bit smart about certain things, but you mostly get it for free from modern search engines, way better bang for the buck. So until you've done those easy things first, don't bother here yet. Okay? That being said, it wouldn't be a talk if I just quit right now. So let's dig in and look at a really simple QA workflow, okay? So over on the left, kind of one of the premises of most modern QA systems, and Watson is no different here, being, you know, kind of the most famous QA system and probably the most popular and well-known. They're all based off of taking in a bunch of content from the web, Wikipedia, etc. And so if that content doesn't have the answer or has conflicting answers or whatever, you have to deal with that, right? So when I asked the question, where or what is Berlin Buzzwords, and it came back with no answers, now you guys know why. Because what I was doing was indexing a snapshot of Wikipedia from, I don't know, 3 or 4 years ago, whatever I have on my laptop. And in fact, I was actually indexing a subset of Wikipedia, something like 10,000 records. So the facts that I can answer are all based off of what I see in that core content, right? So classic case of garbage in, garbage out, or in this case, if there's no garbage in, I'm definitely not getting any garbage out, right? And so one of the things I've got to do is here on the left-hand side, basically as my content is flowing in, whatever it is, I want to do some really simple things. And so this is what's baked into the code. You could add other layers here, but the first thing I do is detect sentences, which is basically, you know, I'm just splitting on periods and things like that. OpenNLP actually comes with a pretty decent sentence detection. In the grand scheme of NLP kinds of things, sentence detection is actually a pretty easy problem, at least for Latin-based languages. If you get into Chinese, Japanese, Korean, etc., then it gets a bit harder, as does just dealing with the character sets and all of that. And then what we do is we go and do named entity recognition. I'll cover a little bit more of what that is. And then we just add those documents into Solr. So now at indexing time, I've got a Solr index or a Lucene index that contains essentially some annotated content. It's the raw original content, that whole big document on 10-minute warning. but it has some extra things added into it. And those extra things will then allow me at query time to do interesting things. And so a lot of the work happens at query time. Obviously, the natural language question comes in. Notice I wasn't doing, like if you're familiar with Lucene and Solr, I wasn't doing, 10 and, minute and, warning, and putting in like Boolean operators or parentheses or any of that kind of stuff. I was actually just letting the person type in real questions, just like you would. In this particular case, English ones, but you could go and train this for German or French or whatever you want to go and do. So first off, we've got to go and parse that query. We've got to split that up into tokens, and we've got to find out interesting things about it. I'll talk a little bit more about what those are. And then this really is the crux of the process here on the query side, is I want to determine the answer type. We'll get into that here in a minute. And then so on down, it's kind of, the rest of it is pretty easy after this, these next two steps basically. How do I convert that answer type in the query into a Lucene or Solr query? And then last but not least, I get a bunch of candidate documents. So if you're familiar with Lucene and Solr, they just return back the raw documents. I've actually got to do something to score within those, and that's what this whole ranking passages, and you can get really complex about this. And if you read, for instance, the Watson paper, they go and do some really advanced ranking around tiebreakers and different data sets and all of that kind of stuff. So far, so good? So that's a very high level, very simple workflow. There's a lot of room for improvement here. I will talk a little bit about some of the room for improvement at the end of this talk, but let's dig into what are the building blocks here. So in the book, this is all in chapter 2. This is kind of in those grain of salt categories: sentence detection, part of speech tagging, parsing. These are all kind of the core building blocks of NLP. How many people remember their high school grammar class? Verbs and nouns and adjectives. How many people liked their high school grammar class? Nobody? Well, okay, so you're an NLP engineer. You can, come talk to me afterwards. We'll get a job for you. So the idea oftentimes, though, is that you're building out structures like this. Anybody remember diagramming sentences in high school? Really fun exercise. Nod your heads, yes. Your English teacher or your German teacher or whatever language would be really proud of you. So in this particular case, like I've got this sentence: the Minnesota Twins, my hometown baseball team, the 1991 World Series champions, are currently in 3rd place. We parse that out. This is a noun phrase, the Minnesota Twins. That whole thing, the 1991 World Series champions, that's also a noun phrase. Together, 2 noun phrases make a noun phrase. Starting to come back to you, painful memories. English, you've got your verb phrase over here. We've got verb and an adverb phrase, are currently in 3rd place. The cool thing is something like OpenNLP actually will do this whole structure for you. And so now we can start to think about how can we leverage that information, right? You can start to, I think, if you're paying attention, you're thinking about, okay, I've got this answer type on the query side, and I've got this structure content over on the document side. Think about how you can fit together those puzzle pieces. But before we do that, let's take a little aside. Everybody familiar with named entity recognition? All right, this is that whole problem of how do I know Bob Jones is really Bob Jones, or whether Bob Jones is actually a person or a thing or something of interest. If you're a Yahoo user, a lot of web news sites these days, it may be a little hard to read in the back there, but in this particular image, like Sarah Palin, everybody's favorite presidential candidate, I'm sure, is underlined. And this system is actually underlining and highlighting named entities in the text. I apologize for the outdated US slide, but it's still relevant. And the idea is then they're hyperlinked and you can click on it and get more information about that person. So NER is this process of extracting proper names. And there's a couple different approaches. We can do rule-based approaches like look for certain keywords together, like, Mr. Bob Jones. So anytime you see the word Mr., then chances are the thing that follows up after it is a person, right? So you can build out these rules, but even better, we can apply machine learning to these kinds of things, and that's really how the modern approach is done to it. But even there, right, you see already one of the hard problems. How is Mr. usually spelled? MR period, right? What ends a sentence, in English anyways? period, right? So you sure that's not the end of a sentence? And then Bob Jones is the beginning of the next one? Maybe it is, maybe it isn't, right? So again, you start to think about how all of these play together. And really at the end of the day, this NER stuff is a pretty critical aspect because it turns out in question answering, most people, when they're looking in these fact-based systems, they're interested in people, places, things. They're interested in named entities. So digging in after that, let's think a little bit about search in this context because most of the work, like I said, happens at query time. The documents indexing side, that code's pretty straightforward. All of it's built out in the book code. You can go and try it really easy. The search side is really where it gets interesting. And what we do in the book is take a custom query parser. So Solr makes it really easy for you to plug in your own query parser. So that's all we did was take and plug in one that can handle natural language. And then the key thing that you've got to be able to do is retrieve what's called a candidate passage. In fact, this is what Watson does. It does it across lots of different data sets. It's really fast at it, and it's really fast at combining them together. And that whole combining them together is that I've got these candidate passages, and I need to go score them. The interesting thing that's different here from search in most cases, when you're just showing 10 blue links, is in most search systems, you just need to know that there was a match. Right? You don't need to know where it occurred. In a QA system, I need to know where it occurred so I can go look around it at the context. Right? And so that's one of the trivial, or one of the key things that's underlying this. Turns out Lucene and Solr have support for this. They're called span queries or position-based queries. They're not really greatly supported. I mean, they're supported, but they're not necessarily first-class citizens. But as Uwe just gave me, they are getting better. Has that been committed? Oh, okay, so in the latest Lucene, never mind, all the like positions and all of this, where did it occur, is now a first-class citizen, which is great because before it was kind of clunky. And so that's one of the key things that we need to be able to do. The other key thing we need to be able to do, like I said, is determine that answer type. Well, the answer type is essentially doing a categorization of the user's question. What is this person looking for? What is their intent? Right? And in this case, we're doing certain kinds of answer types. So in the book, we just use 4 different answer types, but there's hundreds, depending on who you want to talk to and what your system wants. You can go after a lot more of these. So a few examples, I'm interested in a person or a location or an organization or a time point. So you might ask the question, when is Grant's talk at Berlin Buzzwords? Wouldn't that be great if instead of looking on the schedule, you could just say into your phone, when is Grant's talk at Berlin Buzzwords? That would be a really nice feature to have. And so what we're then doing is there's a 2-part process to this. We're going to train an NLP classifier on a bunch of questions. And then at query time, all we have to do is feed that question into that model that was created. So we do the training offline, and then we look up and ask the model at runtime. So for example, here's actually one of the training questions. It's labeled with a P for person, and it says, which French monarch, we all know that we're looking now for a person, reinstated the divine right of the monarchy, blah, blah, blah. You can tell academics came up with these examples. So, it's obviously something, you wouldn't necessarily see on your core website, but you would do the same kind of thing. When is Grant talking at Berlin Buzzwords? Or who is Grant or whoever? You could train based off of those kinds of examples. So now we've got a way of searching. We've got this answer type. There's a little bit of magic there and asking the right kind of question, but if you remember at document indexing time, we're overlaying things like the part of speech and all of that stuff. So we're overlaying onto the document things like this is a noun phrase or this is a named entity. Now at query time I can say, oh, this is looking for a person. That means I want to look for named entities within this scoring passage. And so then it becomes a question of how do I do scoring on this? In the book we present a really simple scoring approach. But it works decent enough for you to get started and feeling like you're making progress. I won't claim that we invented this. It was actually in the early days of question answering back in the 90s. AT&T published this in one of their question answering papers. Pretty simple though is, again, now all of a sudden you can see why I need to know where the match was, because I'm going to look at the matching terms and then I'm going to look at various size windows around those matching terms. Right, so what is trimethylbenzene? I'm finding the word trimethylbenzene and then looking at it around it and then doing some scoring based off of it. In this particular case, it's a really simple scoring. So far, so good? So it turns out then that we can actually do some really interesting things with this beyond. I'm just going to give another little quick demo, assuming that I started it properly. In this particular case, looking at some of the work that we're doing, shoot, I forgot to start it. Let me fire that up. Some of the work that we're doing in LucidWorks Fusion. Fusion is just our product that sits on top of Lucene. And one of the things you start to think about is that, well, if I'm doing this answer type stuff, I don't have to just use that for question answering. I can use that really to try to categorize user intent. And so what we've then done is build into our mechanism, into what we call our pipeline stages, this ability to say that I want to do things like detect what the answer types are and then feed that into downstream applications. So let me just see if that's done starting up. Otherwise, I'll come back to it. Almost done. So here we go. Just pop over to this other window. So in this particular case, what I've done is, let me just get right to my window here. Sorry, search, and I'm going to choose my collection, questions, and I'm going to get back a bunch of content here. Let me just make this window bigger. I'm not sure what's going on resolution size there. You can see what I've got in here is a bunch of tax questions. So this is generated off of user forms for US taxes. Hopefully European taxes aren't as archaic as US taxes, but people spend a lot of time in the US on taxes. And so, for instance, in this FAQ, if you will, you can imagine applying this to any FAQ system. There's people ask questions like, where do I take a deduction for a home office? Right? I don't know if that's a thing over here, but it's a thing in the US, and you can get money back for it. And so what we've done is we've taken all of those questions. Those are essentially our training examples. And you can see, for instance, this second item here. That's my label. That's my answer type. You remember the P in the organization, person, organization. Well, in this particular case, whoever built this FAQ has also assigned labels to them. And so you can see here, I'm actually just searching. I've put all this content in Solr itself, and so then I can build my model off of it. And so we can come in, and then I can ask questions like, if I can remember my exact syntax, how do I take the home office deduction? And good Lord willing, live demos, it works. Okay? And so the interesting thing here that I did is, obviously I'm getting matches on the questions themselves, but I've also done this categorization of the question itself, and that's allowed me to do what's called the landing page in Fusion, or a best bet, if you're familiar with that in most search systems here. The idea being that in this particular case, and I'll show you what the pipeline looks like, I've done a categorization or a classification of the question, and then I've marked that in my processing steps before I even query Solr, and then I've fed that into this landing page thing that just says, oh, if I see this type of category for the answer type, then just automatically attach to my results this landing page or this page that I would redirect to. So for instance, like if you're on the Apple website and you do a search for iPhone, does this show you 100 blue links on iPhone? No, it just shows you, it takes you right to the iPhone landing page. Same kind of idea here. What is this user looking for? What is their intent? Well, if we know, then let's just take them right to the answer. And then I can also add in, obviously, all the question answering stuff that I do too. But you'd be surprised at how many, I bet if you went and looked in your logs, How many people come to your website and ask the same question over and over again? Chances are you're already curating them anyways. So what does this look like real quickly in the pipelines? Let's pop over to this other tab here. I'm going to go look at my questions. And literally with the way Fusion works, you can just drag and drop different pipeline stages in there. In this particular case, I'm in the query pipelines. I'm doing my searches against Solr. I'm setting up what searches or what fields I want to search, and then I've got this little NLP classifier that literally is just outputting to a specific label this category field and using a model that I have stored on my local system. This is all prototype code right now, something that we're working on for the near future here. And so out of that then comes a category label, if it can label it. And then the next stage I have is one of our landing pages stages. And it literally just says, if I've got a match on the category label, in this case, deduction home office, then I want to redirect to this exact URL. And you can apply different strategies to matching and all of that, right? So that's not so much, it's not so much about doing this with landing pages as that's an example of how you could go do this. And in fact, all of these stages will get that context passed in. And then you can see the very last one here is go and do Solr. But so for instance, I might, based off of the category, I might choose different faceting options, right? And then have it automatically display those facets. That's a big problem in e-commerce. So again, like how can I take this user intent and then churn that into something interesting? And then like I said, of course we can go and build proper QA systems and all of that underneath the hood. Just get back to my slides. So I think pretty quickly showed you some of the basics that go into QA. It's obviously kind of a trivial situation. If you've ever written a book, you realize that the whole thing is about writing simple examples that demonstrate the idea without, giving, we get to wave our hands a lot as authors. So a real production system obviously has to do a lot more. I've put up here a number of different ideas around next steps as some things that are interesting that you could do. Even in my, my little Solr demo there where I'm getting back and showing you those actual answers, if you really dug in on that, you would see that it's not really yet the answer. Like I think in some of them I had, I have that window, but chances are you could probably narrow it down to even less than that and say it's this exact kind of piece to it. So extracting the actual answers, there's a fair bit of work that goes into that. Doing things like dealing with duplicates or conflicting answers or all of those kinds of things, that's really a critical part, especially if you're taking in the world's knowledge, if you will, or a really large volume of content. You're going to have people who disagree. How do you decide which one? So, I think a lot of what IBM did was take and figure out good ways of learning the weights of which systems, which data sources to trust and why and when. And that in itself is a machine learning problem as well. You can do other things like, obviously there's a whole bunch of more answer types. Training data is needed on that. I think some of the deep learning stuff that's going on could really help in terms of the feature selection and all of these kinds of pieces. And then last but not least, one of the things like we do in Fusion is we allow you to very easily capture clicks and feedback mechanisms from your user and then feed that back into your search results. And so being able to do those kinds of things where, hey, this user actually clicked on that answer or, grabbed a snippet of it and copied it somewhere else, like giving you an indication that that is the actual right answer, then you can feed that back into your system, right? And you're learning now from what your users are doing. And then obviously over time, your answers should get a lot better, right? We could go on and on here. There's all kinds of low-level engineering questions to be answered and all of that stuff. There's lots of, for instance, I use OpenNLP in the book, but there's things like Stanford NLP and various other natural language processing libraries that are good, if not better. And so depending on, your penchant for doing all of those things, your mileage may vary. So that's it. I think we've got, 5 minutes for questions, so I'm happy to answer any questions. I do have at the end of the slides here a quick on how to get started and run the demo that I showed you. Otherwise, happy for a few questions.
Thank you, Brent.
Thank you.